Today we are going to discuss on a very important aspects of blast furnace operation, which is related 100% to top gas analysis, which act as a vital window into the process efficiency and stability of blast furnace iron making. Now coming to look into the scientific basis which explain that the gas composition is not random. It directly reflects the chemical, thermal and fluid dynamic phenomena occurring deep inside the furnace. Now let us talk about uh, the key components like briefly list the primary gases monitor, which as we all know, carbon monoxide, carbon dioxide, hydrogen, nitrogen, and water are basically the different components. As for the key takeaway from this is concerned, we are going to have a very good understanding on this gas, which allow the operator to see internal condition that are otherwise inaccessible. Now, coming to the key performance indexes, mm, and where efficiency matrix is being shown in terms of formula which is to measure the success, that is eta CO, we called it as a eta CO or CO utilization efficiency, uh, as calculated with a typical target range of 45 to 52. Higher values signify better carbon utilization. Hydrogen, as far the hydrogen reduction is concerned, we also need to see that what is the utilization of hydrogen, and there is a, also most important part which is related to degree of direct reduction, which typically range between 30 to 40% in mostly in blast furnaces. So, a higher direct reduction suggests a greater reliance on the direct reduction rather than indirect reduction. And why this top gas in-depth knowledge is essential, because this is the parameter which can give a signal to us about any abnormal situation, thermal deficit or excess heat balance will be indicated by this component. Now coming to the comparative analysis, as for in the next slide is concerned, this is shown that how different fuel injection change the gas profile. For instance, an all coke operation typically shows while 80 kg natural gas operation increases level to approximately 0.6%. As far the operational context is concerned, it is to be noted that the level varies significantly between operation from 0.1% in all coke to 0.9% in 200 kg PCI. As for the moisture also, we have to remind each one of us that the dry and wet basis also will have a lot of changes. Typically, this accounts for 2 to 5% of the composition variance. Now, coming to the identifying problems which are supposed to be the most important and suitable yardstick where operator need to catch hold of the right reason for any variation in the composition. Now as you can see that CO increase, which is directly related with the incomplete combustion, and we need to enhance the combustion efficiency as a remedial measure. And the same way, Suppose let us take it as a hydrogen which is dipping down. This shows that the bacterial activities, and we also have a required action in terms of adjusting ventilation setting. Coming to one further example, like hydrogen content, which is going down, these also uh, signal direct towards a incomplete combustion level, and we need to see all these things. We have to correlate these warning signs. So an increase in CO suggests, like as I said, suggests incomplete combustion requiring. So we need to catch hold of the right reason for which such things are happening, and like one by one, once we catch hold of the increase and decrease of component of gases in blast furnace, then we can have got a much better understanding. Coming to the case study, on a real world application, we can say that the present data from a 5,000 furnace producing 12,000 ton hot metal per day is shown, and in this specific case the top gas composition remains 55.2%, where CO is 22.1% and 18.3%, resulted in a high carbon efficiency of 92.3% and an energy recovery of 45.6%. So, as far the calculated risk is concerned, this reached to 85.2, demonstrating highly optimized operations for this reference unit. Now coming to the let us move from general gas analysis to radial and vertical profiling, and this gives us a more in depth about the setups where we have got a bottlenecks either in the radial or in the vertical phase. So such things are going to help a lot during our diagnostic approach and corrective measure. So we need to also mention that how sampling occurs across the wall, center and mid radius to ensure the furnace is working uniformly. Similarly, the vertical analysis, we can say that we can have a opinion that highlight that monitoring the vertical gas analysis is also very important, and tracking temperature from 1200 to 600 is a challenge, but we have to keep track, so it helps determining gas residence time and ensure optimal energy recovery. As far the online system is concerned, to conclude with the how this data is used in real time for early fault detection and operators guidance, this is also need to be a strategic integration of this data, and this data feeds into process control system and maintenance management for predictive maintenance. So the golden rule here is end with a central philosophy of the sources. Top gas tells a story of what happened inside hours before the cast house see it.